My title is Discover Cloud Resources, showing you like a hands-on experience how that looks like with Resoto. So I have the slide here to say who I am. I think most of you actually know it. I think the slide basically says I'm old and I have some experience, and we do some engineering doing Resoto for almost a year. So there are two things that I would like to cover, like introduce why would you actually use an asset inventory, like what is it actually? And the second, like giving you a demo to like how would it look like to discover resources. So the problem that I think that starts easy and becomes complex very fast is that there are just too many resources in the world. First, let's look into how many services are available. Like in AWS, there are over 300 services now. GCP has over 50, Azure over 200 services. And like every application that you create, usually you or the developers you work with contains like tens to actually thousands of resources. And by resource, I'm not only thinking about like compute instances, but also something like load balancers, something like SSH keys, something like disks, volumes, snapshots, databases, data streams, like all of that make an application and needs to be maintained somehow. So in a former company, and some people here in the room actually have worked in that company too, we were at some point 200 developers and we had to maintain over 200K resources, which is quite insane. If you do the math, then you would agree that no human can actually manage this level of complexity, and we need a different way to cope with this situation. What is quite surprisingly, it is actually also pretty hard to gather the data. Like if you follow best practices, like from AWS or GCP or also in Kubernetes, they actually propose that you use different accounts, that you use different projects. That's the term in GCP. And I'm pretty sure if you use Kubernetes, then you usually do not have like one cluster, but 2, 3, or even multiple. So we actually work with one user that has over 2,000 GCP accounts and a Kubernetes cluster in each. So like maintaining that is totally possible, but it's really like you need to automate. You cannot do it manually. And the kind of access that you usually get is usually limited for a very good reason, which is security. So you should actually not be able to have like root access and see everything and access everything and be able to change everything. So that's why like your view is usually limited. And if you look into the service that you use, then you also see that like every service has its own like UI, API and model. So in order to understand how this service, like what are the interesting information I need from that service, I actually need to understand every service and every model. There are, like, if you look into Kubernetes, they actually try to be very consistent in their schema. If you look into AWS, like there's a mess all around. It's very different, but overall, it's something that says you need to understand the service in order to gather like data out of that. And the last point that I want to mention is that it's specifically hard to get relationship between resources. So if you have connections between resources, they are most often available as some kind of ID that reference to each other. But there's also something like Kubernetes selectors, which is a cool concept. But to know which kind of relationship there is, you actually need to do the math basically and see which resource is connected to which other. So what we think that you want to have is have a sidekick that's actually able to handle the heavy lifting. So what in this case Resoto provides is one API where you can query all the resources that are available, and it actually doesn't matter like if the resource is coming from Kubernetes or AWS or GCP. It also doesn't matter like in which account this resource lives and in which region it is deployed, and it also allows you to query relationships programmatically, and I will show in a minute what that means. That is what you like get out of it information-wise. And why do you want to use that? You want to use that information in order to keep track of rules, and those rules could be security-related rules or rules that you want to define for your company, that your infrastructure should behave in a certain way. What you can also do, and that's just a very common thing, is to maintain a tag policy, like enforcing that a specific tag is available or not available. Also, one use case is cleanup. Like you want to have like a policy that says when can we actually get rid of this resource. Specifically, if you think think about dev or testing accounts where you can spin up a resource, and we think actually that every resource in that development account should have an expiration tag by default, so that you can say like, if I forget about that, then I know it gets thrown away automatically at some point. And last but not least, getting a grip on code, which not only means being able to delete text, but actually getting insights into who is creating code, being able to aggregate this data in a way that you can really say, like by team or by person or by product or whatever you have to say, like this is what creates code. So here I have a little overview, like how Resoto works. And the idea is that Resoto is installed somewhere, usually also in some cloud environment, and that it actually scrapes the infrastructure that you have, like in GCP, in Kubernetes, in the AWS, in DigitalOcean. So it uses the APIs that all the cloud providers give you to see what has been installed. So, and no matter how it was installed, so if you use Terraform or if you just click on the console to create a resource or whatever, so as long as it has been created, it is available and can be seen by Resoto. And what we take out as data from the cloud is a directed acyclic graph. So that means that every resource that we find in a cloud provider is modeled as a node in a graph, and all the relationship between a resource is modeled as an edge in that graph. And the data structure from that resource, that is actually very specific to AWS, GCP or whatever. So the structure can be very different, but we make sure that we have like a common set of data that you just have for every resource, something like ID, name, tags, age, something like that. So the graph is actually stored in a graph database. We do this scraping of data like recurrently so that we always get a fresh snapshot. And when we create a snapshot, you can also define aggregations that take your graph and then create metrics out of the infrastructure data that has been found. And that is put into a time series database and creates a time series. So something like instances per account region and so on would be an example. For the UIs that we have, like the obvious one is Grafana looking into Prometheus data, but we will show in a minute the Resoto shell, and we also have a Resoto notebook that I will present this in a minute. We also have a UI which is in the making. It is currently very alpha, so something for the next meetup, I guess. So I created this demo and it is available as a notebook, so you can just check it out and play with it yourself if you want to, but I will just show it here. So I used a notebook just because it's very convenient to give you like what do I want to say and also show you the result. It's not that this is very like we do any data analytics stuff yours, but it's actually a nice way. So just to give you a quick impression, so you import Resoto notebook, you say where's your installation, I have everything on localhost. And then you can, for example, do search or CLI execute, and everything that like CLI execute is actually something that which takes a string and then executes it on a CLI. And the CLI is something I want to show. That's actually the CLI. If you install Resoto, then you get a shell where you can just do something, and that something is something I will show. Just that you can like you are not forced to write anything into a web page to interact with Resoto. It's just as an example to show. So the first thing that I would like to show is the full text search. So we maintain a full text search index for all the properties of every resource that you have in your cluster. So if you want to search for anything, just put your search term in quotes, type search, and you will find this thing. So I took here an IPv4 address just as an example. It could be anything else. And as I said, it really doesn't matter like how nested this property is or where it is. You will find it with the full text search. So in this case, and I should have mentioned like all the examples are using Kubernetes resources, because I think that is what everybody probably knows very well. So in this case, we find a Kubernetes service which provides this IP address. So this is something like, think of it as like Googling your infrastructure. Very simple. You do not need to know anything. You just can interact and get a result. And that's what I wanted to show. So Like if you search like this, then you will get one line that shows you some overview data. And if you type dump, then you get actually everything that we know about this Kubernetes service. And that is everything that is in Kubernetes, probably something you know very well. And there's also like this IP address that we've seen. So that is cool, but you most often want to search more specific. And one thing is searching for a specific kind. So that would be something like, is a Kubernetes pod, for example, and you would get all the Kubernetes pods. And this will get you all the Kubernetes pods, no matter in which namespace, in which cluster, and so on. If you want to refine your search, you would use some more criterions. So that is something you can do with and or. So you can combine is and then you have a property that you can refine on. So this is actually regular expressions, Resoto. We have a Helm chart, so Resoto installs in Kubernetes. So the result of that is the pods that a Resoto installation contains. So that is not super interesting. What is probably more interesting, and I really need to hurry up to bring that point across, is something like get the services of a Kubernetes pod, because that is one example where it's actually not easy to go from a pod and say which service actually exposes this pod, and it could be multiple services. And in order to do that, I will show you something like this search that you see here is Kubernetes service and name test service. So we search for one specific service, and what we do here is there is an arrow to the right, and the result of that search is what you see here as an image. So it shows all outgoing dependencies, all resources that are referenced from that service up to 2 steps. So the service, and you see a pod, and then there's a config map that the pods are using. That is the point, the arrow to the right. And you can also do the same query, but with the arrow to the left. And what you get here is the same service, but this time on the right side, because now you get all the resources that are pointing to the service, which are the incoming or inbound relationships. And what is interesting, by the way, just as a side note, you not only get Kubernetes resources here, but you also see who is actually providing the service. In this case, we have it deployed on DigitalOcean. So you see that this is the DigitalOcean load balancer that's actually providing the Kubernetes service. Last but not least, you can also point in 2 directions, which just is the combination of the 2, and you would get like all incoming and all outgoing dependencies. And the cool thing is what you can do with that information is answer the question that I just raised, which is what is actually the service of a pod. I can ask for a pod, in this case with this name here, and then we go, like we walk the graph inbound and filter the resulting list for Kubernetes service, and then is the services, the result is the services that this pod exposes, which is, just to show you the picture here, this is BBW7M, and then we go here and then we get this result. So, and with this you can actually do a lot of interesting things. So something like get me all pods that are behind the service. This is just ask for a service, go outbound and filter for pods. And you can actually combine that. You can actually say, like, I'm starting from a pod, I'm walking inbound to get the Kubernetes service, and then I walk outbound to get Kubernetes pods again, which is the same result that we've seen before. I just want to show that you can actually traverse on the graph as often as you want. Okay, and the last thing, maybe I can show that because it's actually quite interesting to see. You can not only walk 1 or 2 steps, you can actually walk as many steps as you want. This is what this is showing you here. So, and what we do here, we are asking for a pod with the name Resoto, and we say, show me all transitive dependencies that you know. And this picture is actually pretty big, that's why I put it here. Now we can show it in full screen. So this is the result. So this is how a Resoto installation looks inside Kubernetes. You see there are 3 pods. There is a secret. This is the database secret. This is the private shared key that those pods use to securely communicate. Then you see something like the replica set and the deployments that make the pods, and there is a service that exposes the Resoto core. You see the namespace, and what you also see, maybe walk up a little bit here, that the pods are actually living on a Kubernetes node, of course. And the node, if we just go a little bit up further, are actually provided by DigitalOcean Droplet, which is the compute instance in DigitalOcean where the Kubernetes node is running on. And if we go here, then we see that There's a DigitalOcean load balancer. You see like which Kubernetes version we use. You see the droplet size. We only have 1 CPU and 2 gigabytes of data, and everything is deployed in Frankfurt region. So all of this information is like exposed just by asking, give me the information you know from the 3 pods. So that's actually, I think, pretty powerful. There's actually probably more I could tell, but the time is up. So thank you.